What is up, YouTube? Welcome back to another episode on CodeWithAni, and in this particular episode we're going to take a look at the concept of reflection in Java. Reflection in Java. So reflection is the underlying concept behind several frameworks, and it is also the concept behind this IDE suggestions that you see, right? So if I say something like list, right, all the suggestions that you're seeing here, right, list of integer space a list is equal to new. As soon as I say a, it's just lists out all the different types of implementations, right? How do you think the IDE does this job, right? This particular process of identifying what is the implementation or what is happening behind the scenes is through a concept called as reflection. Okay, and this is not just limited to the IDE suggestions that you see here. It is also applicable to all the JUnit and unit testing frameworks that you have out there, right? They also make use of reflection to perform assertions and perform setup and tear down operations on different unit tests that you write. Okay, so more about that in a dedicated playlist on unit testing with JUnit framework. So I'll do a dedicated video just to help you guys understand how you can unit test your code. Okay, but I'm just telling you that the underlying concept behind the frameworks that you apply for unit testing like JUnit is also reflection. Okay, so what is this reflection? Why is it so important or powerful, right? Let me show you one example. So let's say I have a class called student. Okay, now what I'm saying is the student class has two constructors. Okay, and I'm going to say public student. Okay, this is just an empty constructor. There's nothing that I'm going to do here. I'm just going to say no operations, nothing to do here. Other constructor that I'm going to have is simply going to accept a name and age. Okay, now let me have two private variables as well, private int age and private string name. Okay, now what I'm going to say is this dot name is equal to name and this dot age equal to age. Alright, just did the assignment operation here. Let me have two getter methods. Okay, I'm going to say public string get name. This is going to return name. Okay, likewise I'm going to say private int get age. Purposefully I'm making this private to show you one thing. I'm going to say return age. Now as per principles of OOP, let's try to initialize the object for this particular class. Say student space s or student equal to new student. Okay, and this is the default constructor, right? So it accepts and invokes the default one. We are doing no operations here. We don't want to invoke the default. We want to call the one with two parameters here. So I'm going to say a string, let's say Annie, comma age, let's say 24. Okay, oh, age is an integer, sorry. Yeah, now this is set up, right? So the age and name are assigned to the student. Now what we'll do is, if I say student dot get name, I can only say get name, right? Because get age is a privately defined method and it cannot be accessed from the object. What if I want to access and see what is the value that is set to it, right? Okay, there is a way by which I can do that, and that is the concept of reflection. So let's say I say I have a student object here, right? So what I will say is method. Okay, now when I say method, right, with M capital, automatically it shows java.lang.reflect. So this is the package where reflection methods will lie, reflection related classes will lie. So method space get age, I'm gonna call that method as get age, is equal to student dot class, okay, dot get declared method. Okay, and here you can pass the name of the method which we are going to get from there, exact name. So here we have given the name as get age, right? Just copy this name and put it here. That's it. Now it says an error here, right? The error it says is it has an unhandled exception called no such method exception. So let's add that signature here. Why? Because this method that you pass here in the strings, right, it may not even be defined. If I get, for example, get ages, it is free to throw this exception, but automatically it gives you a warning saying that get ages is not here, right? So if I say get age, automatically it will go off. So this by itself is the reflection that IDE is providing you, IntelliJ IDEA. See the beauty of reflection, right? So I'm just saying get declared method get age. So if I click get age, automatically it links to this one also. So look at the level of power of reflection. Okay, so we got the age get age method. Like we are just saying that okay, this is the method and then I'm gonna recreate through reflection. Okay, this is the syntax for it. Then what I will do is, if I want to run this method, right now this is a private method, so what I will say is get age dot set accessible true. Now this is a property that I'm changing. Okay, when I say set accessible, right, what this will do is it will be able to enable the access to that method, because it's a private modifier method. I'm not able to access it to the object through traditional access, right, using the object, using the instance of student class. But if I do want to do that for the sake of testing or whatever the purpose it is, then I can simply say use this particular method instance and use set accessible on top of it and set it to true. Now what I can do is system.out.println. Okay, I can say get age dot invoke. I have to pass the student object because that's the one that is used to create this instance, right? So I'll pass in that instance to the invoke method. Okay, now invoke also gives you an exception, says that there is illegal access and invocation target exception. So I'll just add those as well to the method signature of throws. As you can see here, the reason that I'm adding these two here is because, and the reason these can also be thrown is because your particular operating system, right, it may have some restriction. It may not allow you to give the permission to access this particular method, or the JVM might not be able to access. So that's the reason why you have this particular throws exception. It may or may not be able to. So that's why we, for safer side, mention the invocation target exception is checked exception that wraps an exception by an invoked method or constructor, because if you have not set this accessible to true, it will automatically throw either of these exceptions, invocation target or illegal access exception. Illegal access because when an application tries to reflectively create an instance other than a set or field, get a field or invoke a method, but the current executing method does not have access to the definition of the class field. Specifically for this particular use case, they have designed this illegal access exception, and that is the reason why, to circumvent that, you have to set the accessibility to true, set accessible true. So 3-step process. Define the method that you want to get the access to. In this case, it is get age method. So this is the syntax for it. Set accessible true. Then let's try to invoke the method. It should print out the age 24 for us. Let's try to run this one. Okay, let's run it. Yeah. See, so you have successfully invoked a private method without actually using the original instance, but using the reflection concept here. Okay, not just this, reflection will also be able to tell you how many constructors you have in your particular code. If I say constructors equal to student.class dot get constructors, right, it will list out all the constructors that are present here. So you can simply check out the size of the constructors and show that constructors dot length, it should print out 2, because there are 2 constructors here, right? It's saying raw use of parameterized constructor. Basically, it is no type you are mentioning. It's just saying student.class.get constructors. I think it expects a generic type of student, I think. Oh, okay. So it's still fine. You can use the raw one. That is okay. Oh, all right. So let's try to run this as well, and we should be able to see the value 2 here. Generally, when it says raw usage, right, it refers to the raw parameterized. Raw usage is basically a usage without specifying the type. Okay, yeah, see 2 constructors out there, so it has printed both of them. Okay, you can individually iterate and find out the name of the constructor. Name of the constructor is anyway the same as the class name, right? So that is the property of constructor, the special method which has the same name as class name. So likewise, you can even access private fields as well. So if you, same way that you did here, right, method.getAge, you can say field.age or field.name I can get simply. Okay, field space name equal to same thing, student.class.get field, and you can simply pass name. See, it automatically suggests that also. And here also it can throw no such field exception, so we'll add it. Just like no such method exists, no such field can also exist. Okay, it says field name is not public, it's private, but we'll try and see if we can access the private field. Okay, and I can say simply that this is a particular string, right? So I'm just going to say string of this thing. I think we can simply, okay, maybe not like this, sorry, the other line should come in. So this is string value of the name equal to string typecasting the name dot name dot get name or get object. Let's try out get object student. Let's see what it returns, and we'll just print out the value of name. Okay, because I've set it to whatever name here, Annie, right? Annie should be printed here properly. Let's see what happens. Oh, we got an error. No such field exception. Why? Oh, name does exist, right? Oh, maybe then private names are not in scope, I guess. You cannot directly access them because it says here name is not public. Use get declared field. Oh, you have to use get declared field. Sorry, not get field. Now let's try it out again, because we use get declared method, right? So get declared field or get declared method is basically specifically built for private modifiers. Again, we got an error. Let's see what is it. Illegal access exception. So it's not allowing us to access the member modifier with private, as you say. Okay, because I have not set the accessibility. See, that's the error that I will showcase here also. Accidentally I forgot, but I get a chance to show you, right? If you don't mention this set accessible, right, it'll automatically throw this one. So when you're getting it, just say name dot set accessible true. Now let's run it. Hopefully I don't run into any more crashes here. This is what happens when you do live coding. Okay, we got the name here, Annie, right? So that's the point of reflection after all, right? The purpose is to make sure that you access something inaccessible to test overall what your class is capable of. Okay, even if your declared methods private for someone to not access it, but you yourself want to test it out whether it's working properly or there's no logical confusion there or some mistake there, you can use the reflection to test it out. And that's what the testing frameworks also use internally, which I'll do in a different playlist. So that's it for this video. I hope it did not stretch beyond 10 minutes. If it did, I apologize for that. And that's it for this topic. Hope you liked it. Hit the like button if you like this video. Subscribe to CodeWithAni if you haven't already, and I'll see you guys in the next video. Bye bye.